students, I am Dr. Shashi Chabra, PGT Chemistry from Kendriya Vidyalaya Sangathan. Welcome to chemistry class. So, let us begin our today's session on amines. Dear learners, in previous session you have learned the following topics, that is the physical properties of amines, that is the boiling point and solubility. Second, basic character of amines both in vapor phase as well as in aqueous phase. Then effect of electron withdrawing and electron releasing groups on the basic character of amines, and also the different chemical reactions of amines, that is acylation reaction, carbylamine reaction and diazotization reaction. Students, today I will discuss a few points regarding Hinsberg's reagent and diazonium salts. Before the discussion about the topic, I would like to share some learning objectives. These are to distinguish between primary, secondary and tertiary amines with the help of Hinsberg's reagent, to study electrophilic substitution reaction in aromatic amines, that is bromination, nitration and sulfonation, to learn methods of preparation, that is physical and chemical properties of diazonium salts. Dear children, let us begin with the reaction of amines with aryl sulfonyl chloride, benzene sulfonyl chloride, which is also called as Hinsberg's reagent, reacts with primary and secondary amines to form sulfonamides. First, the reaction of benzene sulfonyl chloride with primary amine yields N-ethyl benzene sulfonylamide. The hydrogen attached to the nitrogen in the sulfonamide is strongly acidic due to the presence of strong electron withdrawing sulfonyl group. Hence, it is soluble in alkali. Second, in the reaction with secondary amine, NN diethyl benzene sulfonamide is formed. Since NN diethyl benzene sulfonamide does not contain any hydrogen atom attached to the nitrogen atom, it is not acidic and hence insoluble in alkali. And tertiary amines, they do not react with benzene sulfonyl chloride. This property of amines reacting with benzene sulfonyl chloride in a different manner is used for the distinction of primary, secondary and tertiary amines and also for the separation of a mixture of amines. Next, we will move on to electrophilic substitution. The first one is bromination. Dear learners, you can see in the slide that aniline reacts with bromine water at room temperature to give 2,4,6 tribromoaniline. A very important point is, if we have to prepare monosubstituted aniline derivative, then the activating effect of amino group can be controlled by protecting the amino group by acetylation with acetic anhydride. Then carrying out the desired substitution followed by hydrolysis of the substituted amide to the substituted amine. Students, we will now discuss about diazonium salts. Diazonium salts have the general formula RN2X negative, where R is aryl group and the counter ion X minus may be a chloride, bromide or hydrogen sulfate or a tetrafluoroborate ion. The diazonium group consists of two nitrogen atoms triply bonded to each other with an overall +1 charge. Aryl diazonium salts are used as intermediates to synthesize a wide variety of organic compounds. To name diazonium salts, add the word diazonium to the name of the parent hydrocarbon. This is followed by the anion name. Consider the compound shown here on the right hand side. There is a diazonium group plus an ethyl group at position 4 on the benzene ring with the chloride ion. The correct name of this compound is para-ethyl benzene diazonium chloride. Aryl diazonium salts are stable only for a short time at low temperatures. Resonance structures help to stabilize the ion by delocalizing the positive charge around the aromatic ring as presented in the slide shown. So, dear children, how to prepare aryl diazonium salts? Let us see together. Aniline is reacted with nitrous acid at 273 to 278 Kelvin. The nitrous acid is generated in situ by the reaction of sodium nitrite with hydrochloric acid. The overall scheme is summarized here. Due to the low stability of the diazonium salt, it may be used immediately after preparation. Dear learners, let us move on to its physical properties. Benzene diazonium chloride is a colorless crystalline solid. It dissolves readily in water. Next, it is stable in cold water but reacts with warm water. Children, please note that benzene diazonium fluoroborate is insoluble in water. It is stable at room temperature. Now, let us discuss about its chemical properties. The reactions of aryl diazonium salts can be sorted into two classes. First one is reactions involving displacement of nitrogen. Here, many reactions of benzene diazonium salts involve the displacement of the diazonium group, as nitrogen is an excellent leaving group. Second, the reactions involving retention of diazo group. Here, aryl diazonium ion can also undergo coupling reactions using the nitrogen atom of the diazonium group to link to another aromatic ring. Let us first consider the reactions that involve the displacement of the diazonium group. The first group of reactions that we will discuss are known as Sandmeyer reaction. Students, you can carefully see that in these reactions, the diazonium group is replaced by a chloride, bromide or cyanide ion in the presence of copper, and nitrogen molecules are released as a byproduct of the Sandmeyer's reaction. Children, the second reaction that we will discuss is known as Gattermann reaction. In the Gattermann reaction, diazonium group is replaced by a chloride or bromide group. To carry out these transformations, the diazonium salt solution is treated with the appropriate halo acid in the presence of copper powder. In general, yields for the Gattermann reactions are lower than for the analogous Sandmeyer reactions. Next, the diazonium group can also be replaced by iodide ions. If the diazonium salt solution is treated with potassium iodide, this reaction forms iodobenzene as the primary organic product. Remember, you should recognize the steps involved. Step 1 produces an aryl diazonium ion. In the step 2, treatment with the potassium iodide replaces the diazonium ion with iodine. Then, Bals-Schemen reaction is a method for making aryl fluorides. Students, see carefully that in the first step, a primary aryl diazonium salt is treated with fluoroboric acid to make an aryl diazonium fluoroborate which precipitates, and then in the next step the dry diazonium fluoroborate is heated until it decomposes, releasing an aryl fluoride. Now, coming to the next reaction, that is reductive deamination of primary aryl amines that replaces the amino substituent by hydrogen using a diazonium salt as an intermediate. When the diazonium salt is treated with the mild reducing agent such as hypophosphorus acid, sometimes known as phosphinic acid. The disonium ion is reduced to an arene. Alternatively, this can be carried out using ethanol. When the disonium fluoroborate is heated with aqueous sodium nitrite in the presence of copper, the disonium group is replaced by a nitro group. Phenols are readily produced from disonium salts. These reactions cause the disonium group to be replaced by a hydroxyl group. To carry out these reactions, acidify an aqueous solution of the disonium salt by adding sulfuric acid at 100 degrees Celsius and heating it. Dear learners, let us now look at the coupling reactions. Azo-coupling reactions are the electrophilic substitution reactions that take place when disonium salt is reacted with the phenol or aniline derivatives. Students, have a look at the screen. That in these reactions, the disonium cation act as an electrophile, while the electron-rich compounds such as phenols and amines act as a nucleophile. The aromatic rings are joined by the nitrogen atoms. The azo products of the coupling reaction have extended conjugation involving both the aromatic rings. As a result, the products are highly colored. They are often used as dyes. For example, para-hydroxyl azobenzene is an orange dye and para-amino azobenzene is a yellow dye. To conclude, disonium salts are very good intermediates for introducing a variety of functional groups onto an aromatic ring. They allow for substitution patterns that cannot be prepared by direct substitution of benzene or substituted benzenes. So, dear children, this was the last topic of today's session. Hope you all have understood all the concepts well. And now, it is the time to recap what we have studied in this session. That is, primary, secondary and tertiary amines can be distinguished with the help of Heinsberg's reagent, that is, on reaction with benzene sulfonyl chloride. We have studied the various electrophilic substitution reactions in aromatic amines, that includes bromination, nitration and sulfonation. Due to the low stability of the disonium salts, it must be used immediately after preparation. And we have got to know about the two important name reactions, that is Sandmeyer reaction and Gettermann reaction. In general, the yields for the Gettermann reaction are lower than that for the analogous Sandmeyer reactions. Dear children, now it is time for the home assignments. Please note down. The first question is, what happens when aniline reacts with bromine water at room temperature? Write the chemical equation involved. The second question is, write the chemical test to distinguish between primary, secondary and tertiary amine with suitable example. Question number third, write a short note on A is Sandmeyer reaction, B Gettermann reaction and C coupling reaction. Dear learners, that is all about amines. Hope you all have enjoyed this session. Thank you, goodbye and stay blessed.